Hi everyone, we are Team N player, and our members are Xu Han, Jiayuan Tian, and Zayan Du. So our project is done with regard to the Kaggle competition of classifying the components of handwritten Bengali. And below you can find the links to our blog post and GitHub repository. So I am Zayan Du, and I will start with some background information about the competition and introduce our baseline model. Then Jiayuan will introduce the ResNet model. Next, Xu will introduce the EfficientNet B3 model as well as the Ensemble model. And she will also talk about the next steps in the end. So now I will talk a little about the background. And Bengali is the fifth most spoken language in the world. And due to its popularity, there are great business and educational values in developing AI recognition of this language. So in total, there are 49 letters, 18 potential diacritics, and approximately 13,000 grapheme variations. And as we can see that the complexity of the language adds more challenge to the competition. So for this project, we will apply various deep learning models to classify three constituent elements, given the image of a handwritten Bengali grapheme. And these three elements are grapheme root, vowel diacritics, and consonant diacritics. So before I go into introducing our baseline model, I will first explain how we preprocess the given image. Initially, we started with an image of size 137 by 236 pixels. And in order to achieve faster training time and to avoid explosions of memory usage, we resized the image to a size of 64 by 64 pixels. So we first look for the auto threshold, and the auto threshold is an optimal threshold which helps us to separate foreground and background. We use it to look for the contour. So the contours are a useful tool for shape analysis and object detection and recognition. And finding contours is like finding white object from black background. And using the contour we found, we could then locate the bounding box for the characters. We crop out the bounding box containing the characters and resize the image to a size of 64 by 64 pixels using CV2 interpolation. And now I will introduce the baseline model. Our baseline model uses a typical CNN architecture, and we stacked multiple convolutional 2D layers, each one generally followed by a ReLU layer, then batch normalization, the max pooling layer, and then dropout layer. Meanwhile, we doubled the number of filters until 256 filters as we approach the output. Because the pooling layers divide each spatial dimension by a factor of 2, we can afford to double the number of feature maps without exploding the number of parameters, the memory usage, and the computational load. We also inserted a max pooling layer every few layers in a CNN to get some level of translation invariance at a larger scale. And since this is a classification task, max pooling offers a small amount of rotational invariance and a slight scale invariance. Note that we also used different kernel sizes to capture patterns at different scales. And in the end, we flattened the inputs and used a fully connected network. So based on the validation loss portrayed in the graph, we can see that the loss continues to decrease without any sign of going back up again. And this indicates that there is no sign of overfitting in our case. And finally, we achieved a performance score of 0.9516 and a private score of 0.8878. And now Jiayuan will take it on from here to introduce the ResNet model.
Thank you, Daisy, for your introduction, and this is Justin. So I will talk about ResNet model. ResNet is the abbreviation of residual neural network. It is an artificial neural network which builds on a convolutional neural network. It uses skip connections to build a shortcut to send input past several convolutional layers. So it is very common to use CNN to solve image classification problems, especially as the depth of the network and the complexity of the model increase. The network performs better and will contribute to more accurate predictions. However, as the complexity of the model increases, and as the number of the layers increases at the same time, there will be a problem. So if the network is too deep, we might have a problem of vanishing gradients. So some of the layers might not learn anything, and the training process will be very slow because there is no update on the value. Um, so ResNet could solve this vanishing gradient problem by reusing the activations from a previous layer until the adjacent layer learns the weights. Also, after solving the problem, ResNet could also speed up the training process and save more time for us. Next slide, please. So we constructed the resonant model based on the baseline model. After building the basic layers, we extended the network with the residual units. But what we did differently was that we constructed 18 residual units, and each unit had 2 convolutional layers. So we had 36 convolutional layers in total. And among the 18 residual units, we have first 5, which contain 128 feature maps. And next, 6 of them have 256 feature maps for each. And then the last 7 units have 512 feature maps. And after flattening, as a result, the overall score is a little bit better. It's 0.957. And next, Hannah will introduce another more advanced model.
Thanks, Justin. This is Hannah, and I'm going to talk about the next model that we use, that is EfficientNet B3. We know that the deeper the model, the more pixels we preserve, the higher accuracy score we will get. However, training a large model requires a lot of computing resources, and actually the marginal gain in accuracy will reach a plateau. So EfficientNet came up with a formula to strike a balance between model complexity and accuracy. That's why we want to use this model. Before feeding the data to the EfficientNet model, we actually use very simple resizing to process the images and only kept the original, and we will kept the original length and width ratio. We didn't use any data augmentation technique at all. So we load the model with pre-trained weights from Keras and freeze all the layers, add a generalized mean pooling layer with one learnable parameter, and finally followed by fully connected layers. So according to our research, the paper called Fine-Tuning CNN Image Retrieval proposed this idea of GEM layer and proved that it offers a significant performance boost over standard non-trainable pooling layers. And here you can find our implementation of the generalized mean pooling layer. So as you can see, the training, since we load the pre-trained weights from a pre-trained model, I think this will greatly help us reach global optima faster. And that's the notion of transfer learning. And since root is the most difficult category to classify, we will assign a weight of 0.4 to root. So after training for 80 epochs, you can see so the final score, so this is the public score for one epoch. So this epoch 53, and we can see that EfficientNet offers 1% absolute increase from ResNet for the public score. And finally, we try to ensemble several checkpoint models from training EfficientNet B3. And we actually use a simple averaging method. That is, we took the average logits value from softmax outputs from several models and choose the label with the largest average logit value. And this further help us increase the public score to over 0.97. So next step. So actually we tried DanceNet 121 as well, but since we didn't have a very powerful GPU, we couldn't continue the training process. And so we would like to further train our DanceNet model and use a more powerful GPU to continue training the model. And also we would like to try the newest state-of-the-art data augmentation techniques used by players in the Go zone, such as cut out, cut mix, mix up. As you can see, so the mix up is actually mixing two images together, and the cutout is cutting out a portion of the image, and cut mix is to cut a portion of one image and put it on top of another image. And I think all this technique should help our model generalize better. And last but not least, thanks for listening to our screencast. And I hope that you find our work useful.